Hello everyone, I'm Valérian Fraisse, postdoctoral researcher at McGill University, and today I'm going to talk about a multidisciplinary project around the design and evaluation of a public space sound installation in Paris. The project involves the collaboration between researchers from McGill University, Montreal, and IRCAM Paris, as well as the sound artist Nadine Schütz in residency at IRCAM. Here, I'm going to focus on the methodological development of a laboratory study to explore the contextual responsiveness and the acoustic reactivity of a sound installation. First, let's dive into the key concepts and objectives of this talk. Cities often consider urban sounds as noise, a pollution that should be mitigated. However, and while some sounds can definitely annoy us, or have a negative impact on health, others can help us orient ourselves, relax us, energize us, and overall diversify our sensory environments. Overall, sound plays a critical and complex role in the way we perceive urban spaces, and can instead be considered as a resource. The soundscape approach is required to tackle this complexity when thinking about urban sound environments. And when I say soundscape here, and for the purpose of this talk, I mean the human experience of sound environments. Otherwise, sound artists who work in public space have the potential to design or redesign urban soundscapes through sound installations. Sound installations can be defined as places articulated spatially with sounding elements for the purpose of listening over long time spans. However, if sound installations can shape the experience of public space users, the impact of sound art in public spaces is not well documented. Sound installations in public spaces interact with ever-changing urban sound environments characterized by vast temporal, spatial, and spectral dynamics. For this reason, it may be interesting to investigate how installations can coexist with the pre-existing sound environment both acoustically and semantically. To investigate the matter, it might be interesting to consider the concept of acoustic niche. This concept, drawn from acoustic ecology, explains how animal species coexist within major ecosystems by differentiating their vocalizations in both spectral and temporal dimensions. So, a general question we try to assess here is whether we can translate this concept into design principles for sound installations in public spaces. In fact, this concept is the guiding principle for the Niches Acoustiques sound installation. Niches Acoustiques is a permanent sound installation that will be deployed in the forecourt of Paris Judicial Courthouse by sound artist Nadine Schütz. A key principle behind the design of the sound installation is to operationalize the acoustic niche concept by reacting to its surrounding environment in two ways. First, through compositions that are linked to the contextual dynamics of the space, be it in terms of the time of the day, days of the week, or the usage patterns of the space. Second, through the real-time acoustic reactivity of these compositions to the temporal and spectral dynamics of the pre-existing sonic environment. And by reactivity, I really mean here that parameters of the sound installation, such as its level, the spectral content, are adjusted in relation to the surrounding acoustic environment. In this presentation, I will talk about the development of a laboratory study involving the design and evaluation of the Niches Acoustiques sound installation. The study has two main research goals for which we present the associated methodological development. First, we seek to understand the impact of Niches Acoustiques composition on a range of soundscape variations. To do so, we need to create representative laboratory scenarios. Second, we seek to determine strategies for implementing the acoustic reactivity of the composition to the pre-existing sound environment, and to do so, we want to simulate the installation's acoustic in the laboratory. Before I delve into the methods, I want to stress that this research is the result of constant interactions with the sound artist, Nadine Schütz, as part of a multi-stage project spanning over several years. So, all of the methodological developments I'll present next are the results of joint decisions between the research team and the artist. And this collaboration involves several tests in the lab before deploying and evaluating the permanent installation on site. The goal of the study I'm presenting today is to focus on the reactivity implementation. So you can see here a flowchart of the overall experiment setup. The experiment is based on 4 principal elements. First, the simulation of the pre-existing sound environment based on high-order ambisonics recording and their addition into scenario loops corresponding to different time periods in the public space. Second, the presence of the sound installation is simulated. To do so, we send the compositions into a oralization unit that was parameterized to simulate the acoustic propagation in the studied space. Before being oralized, compositions are sent into a reactivity module that simulates the installation's reactivity based on measurements of the ambisonics scenario loops. Finally, both the recordings of the sound environment and the added sounds are fed into a 3D listening room for momentary soundscape evaluations with participants familiar to the public space using semantic differential scales. And these tests were followed by semi-structured interviews. In this talk, I will especially focus on the elaboration of the scenarios and the implementation of the reactivity. Let's delve now into the elaboration of the scenarios. The scenarios are based on high-order ambisonics recordings that were taken in a public space covering various time periods over a total of 9 measurement sessions. From these recordings, we created several loops of around 3 minutes, called scenario loops here, each of which were associated to a specific time period, a pattern of space use, and a narrative in the form of a short script. You can see here a map of the public space in which the Niches Acoustiques sound installation will be deployed. Speakers are placed along poles at 4 positions throughout the space. To capture the sound environment, we conducted recordings at various measurement points throughout the area. From these recordings, we created 6 scenarios across multiple listening sessions with the artist, which are based on the temporal dynamics of the space, but also on a prior analysis of activities done in the forecourt. For the listening tests, each scenario is associated with a narrative and a composition curated to the context. For instance, the afterwork scenario represents an environment dominated by human presence and traffic noise with the following narrative. It's early evening on a weekday, you wake for a moment near the metro entrance, chatting with your colleagues or watching passers-by before heading home. Let's listen to an excerpt of the scenario loop. And now, the associated composition. Another example is a quiet time scenario, representing a quieter environment on a weekend day. The narrative is as follows. It's late morning on a weekend, you take a stroll and stop on the forecourt for a break. Let's listen to an excerpt of the quiet time scenario loop. And now, the associated composition. Let's talk now about the implementation of the acoustic reactivity. As I said before, the reactivity is simulated inside the laboratory based on measurements of the scenarios inside the listening room used for the study. We propose two main strategies for implementing reactivity. First, a tracked approach in which reactivity follows acoustic trends. For instance, if the surrounding sound level is rising, the installation's gain is rising too. Second, an inverse approach whereby compositions occupy acoustic niche. So, for instance, if the surrounding sound level is rising, the installation's gain would decrease in that case, which would correspond to operationalizing the acoustic niche concept. Overall, acoustic reactivity is operated both on the temporal and spectral dimensions. On the temporal dimension, reactivity is based on rolling averages of root mean square values from the measurements used to apply temporal filters on the composition. The intensity, delay, and direction, tracked versus inverse, can be adjusted to create the final experiment conditions. On the spectral dimension, reactivity is based on third octave levels from the measurements. Similarly, the intensity and direction, tracked versus inverse, of the filters can be adjusted. Overall, there's a wide range of variables under study, and we needed to narrow down the experimental conditions in preparation for the laboratory study. To do so, we first identified two general approaches to acoustic reactivity, fine-tuned by the artist through listening sessions. The first approach is called here data-driven, whereby reactivity parameters such as filters intensities are chosen by the artist but remain unchanged throughout the scenarios. In other words, the same filters are applied to all the compositions and scenarios. The second approach, called artistic here, consists in tailoring the reactivity parameters by the artist for each scenarios and composition, and different filters are also applied separately on the composition layers. Through these two approaches, we want to assess whether an artistically informed approach to reactivity yields better results than an automated approach that is only based on measurements. Finally, let me introduce you the soundscape evaluation. Since the methodological development, we conducted the experiment across a total of 37 participants. I won't have time to present the results in detail here, but I will focus on some tendencies. The detailed result analysis will be published in a forthcoming publication. But first, even though we identify general approaches to reactivity, data-driven and artistic, we still need to narrow down our experimental conditions to make it doable for one person to evaluate all the different soundscapes in a single listening experiment. We thus run two pilot studies in order to limit the range of experimental conditions. We finally retained 5 conditions: the pre-existing soundscape with no sound installation, a condition with the installation but no reactivity, 2 data-driven conditions corresponding respectively to the inverse and tracked approaches, and finally, a condition corresponding to the artistic approach to reactivity. We also narrowed down the scenarios to only 3 for a total of 15 conditions in a randomized, repeated measures design. Participants are invited to assess the different conditions through momentary evaluation on semantic differential scales. So you can see here a screenshot of the interface used by the participants. These scales have been informed from previous studies on niche acoustics and other sound installations and include questions relative to sound source dominance on the left and the overall soundscapes on the right. The soundscape scales pertain to 3 main dimensions: pleasantness, familiarity, and variety, which can be associated to eventfulness. The listening tests were also followed by qualitative interviews. For instance, you can see here the soundscape evaluation corresponding to the 5 conditions for the afterwork and quiet time scenarios. First, we see different results for different scenarios. In other words, the composition is impacting different subsets of scales depending on the scenario, and this highlights the importance to investigate different scenarios. Further, we see an interaction between the scenario/composition and the reactivity. On the one hand, when the environment is quiet, there is a preference for the data-driven inverse approach, which exploits the acoustic niche concept, and when it is buzzier, there is a preference for the data-driven tracked approach. probably because the latter leads to a more backgrounded presence of the installation in contexts that are already busy. Otherwise, the artistically informed approach always yields results comparable to the data-driven approach that works best depending on the scenario, and this goes in support for such a tailored approach. To conclude, here are the main contributions. First, we developed a method for evaluating the soundscape impact of acoustically reactive sound installations. We believe this may be transferable to other laboratory soundscape studies, especially for assessing soundscape variations over time, which is oftentimes a limitation in laboratory soundscape studies. They rarely consider the same space at different time periods. In addition, the process could help inform the design of other sound installations in public spaces, where the artist has to take into account the relationship with the pre-existing sound environment. In this talk, I focused on the methodological development, but the publication included a full-fledged analysis of the quantitative and qualitative results is forthcoming, so stay tuned. Thank you so much for listening. Feel free to ask me questions, I'll be happy to answer.